It is not running. Just pardon me. Yeah. So now this is the course contents of the lecture. So there are 5 components of this lecture: choosing the right statistical test. Second one is the parametric test and non-parametric test. Choice. Third one is a choice of a statistical test from the paired or matched observation. And fourth one is the choice of statistical test for independent observations. And the fifth one, the parametric and non-parametric test for comparing two or negative. So these are our contents for today. I do not know whether the time will be sufficient for me or not, because it is a vast thing, because there is both parametric and non-parametric and many things are there. So let me go to the things so which will be in the consideration. So let me see the consideration part. So these these will be the considerations. So now you see under consideration and discussion. So we have made two sides. One is the parametric test side and non-parametric side. So these are the parametric sides we have to consider, and these are the non-parametric sides we have to consider in the today lecture. And some the green things are there which is beyond our capacity, because it is the social science and it is a little bit advanced one, so we will not go for this one. So basically we'll cover all these things and we'll try our level best to do all these things. Then we have to see this one also. So now under the consideration also, one sample test we have to see, two sample tests we have to see, and under two samples paired and unpaired things. And for each of the two samples, for one tail test what will be done, for two tail test what will be done, and for the case samples both paired and unpaired, and for one tail test and for two tail test. And also we will see the large samples, and it varies from sample to sample. Sometimes we are taking the sample size greater than 20, and sometimes sample size greater than 25. If it is the case, what will be happening? Then factorial logistic regression and discriminant analysis, ANOVA, canonical correlations, and factorial analysis. So these are the considerable parts so which we have to deal. So now we have to go from the introduction part first of all. So now in the introduction, first of all, we have to see the uh, when we discuss the application and uses of parametric and non-parametric statistics, we need to remember that they are mainly based on whether assumptions have been made or not. So this is very important thing. So first of all, we have to know where the parametric test will come and where the non-parametric test will come. So for that reason, we have to see what are the assumptions behind the parametric test and non-parametric test. Then after we have to see for making the inferences about various population values, means parameters, we generally make use of parametric and non-parametric tests. And in the parametric statistical test specifies certain conditions such as the data should be normally distributed, which is most important thing for the parametric test. So if the data set is not normally distributed, so we cannot use the parametric set. That is the most important thing we have to consider. And parametric tests normally involve data expressed in absolute numbers or values rather than ranks. So rank should not be there and absolute number should be there. An example includes the student T test and J test and the F test, which are the common parametrical statistical tests. And in form of the non-parametric test is also known as the distribution tree, because there is no such distribution and there is no such normal distribution is followed in these non-parametric tests, and data are generally ranked or grouped. And for example, in the non-parametric test, the common non-parametric test we are using the chi-square test and Spearman's rank correlation coefficient test. So now, after giving some sort of introduction about the parametric and non-parametric, now we have to go for some sort of classifications of variable, because if we are not knowing the variables, then it is difficult for us to understand. So now in the classical classification of variables, so now the variable is of two types. One is qualitative variable and second one is the quantitative variable. So qualitative variable is usually termed in form of the ordinal way. That means it is ranked. That means you can say who is higher and who is lower than others. So this is the ranks. Or you can say there is no such number. So that is ordinal approach we are using in the qualitative variable. And when the quantitative variable is coming, quantitative variable has three types of shapes. Maybe quantitative variable, maybe ordinal in form, maybe discrete in form, maybe continuous in form. So discrete means say natural numbers, 1, 2, 3, 4, 5, 6, any natural number you can take, that is the discrete number. But continuous, you can see that 0.5, half, and 0.7, 0.3, 1.5, 1.7, like this. This is the continuous variable you can find it under the quantitative. So now further, this continuous quantitative variable is divided into two other parts. One is interval variable and another is the ratio variable. So ratio, as you know, 1 by 2 or 2 by 3 or 3 by 5. So this is one type of ratio format. And interval, some sort of range is there. Just like I'm telling, the temperature is varying from 25 to 40%, or 25 to 40 degrees Celsius or centigrade. So that's the interval. So in this way, the variable is classified, because this is important one on thing. Unless we are knowing the classifications of variable, it is very difficult to digest the parametric and non-parametric test. So now the main question comes that four types of scales used with the level of measurement. So when we are going for the level of measurement, so there are usually we are using the four types of scales. So one scale, the first scale is the nominal scale and otherwise known as the categorical scale. So now in the categorical scale, either you can say the sex, that means male or female, that is categorical. So that is nominal or the categorical, or you can put the male as the 1 or female as the 2 or male as 1 and female as 0, like that. So this is called as a nominal scale or the categorical scale. And second type is ordinal scale, which deals with the interval data, and example is the degree of satisfaction. So how much you are satisfied and how much you are dissatisfied, it is based upon your thinking. So no other person can perceive, no other person can justify, and no other person can tell that how much you are satisfied. So it is only your perception, that means it is ordinal approach. So degree of satisfaction is coming under the ordinal scales, and it is in form of the interval data. And interval scale, the third one is the interval scale, which deals with ordered data with interval. And this is a constant scale but has no natural zero. So natural zero is not available here in this case. And differences do make sense. Example includes temperature in centigrade and Kelvin. So this temperature is good example of the interval scale data. And the last but not for the list of the types of scale is ratio scale, which deals with the order, and the constant scale with a natural zero. Now you see here there is no natural zero, but here it is natural zero. And example includes height, weight, age, and length, etc. So now we have to go for already we have discussed it, and now we have to go for the features. So now under the features of the assumptions, the NPS means non-parametric statistics. So now what are the assumptions of the features so that we can categorize that this is the non-parametric side and this is the parametric side. So based upon that, we have formed some sort of assumptions, and we have ready-made features. So from seeing that features of the assumptions, we can categorize that yes, it is coming under the non-parametric side. So please, the dear scholars, please just note it. And this is very important one. And it deals with small samples. That means the number of samples must be less than equal to 30. So if it is greater than 30, it will be a large sample. So that means the NPS will be utilized only when there is a small sample case. So that's the first assumption of features we can see. And observations from several different population at a time. Data is skewed. Data is skewed. It is not normally distributed. It is skewed data, isn't it? So already I told in the introduction part that NPS is not having the normally distributed data. So it is a skewed data. And second one is sample is in the form of nominal and categorical. or numerical scores or ordinal scale sample is from a heterogeneous population. So these are the main things. That means it comes from the heterogeneous population, and it is in form of either nominal data or categorical data or numerical scores or ordinal scale. So these type of possibilities are there in the NPS. So when the data can be expressed in form of the ranks or in the shape of plus and minus sign and the classifications like good or bad. So in this case also you can use the NPS, that means non-parametric test. Some sort of sign will be coming, that means plus or minus. Let's say you are telling good is plus and bad is minus. So when you are expressing in that, or you are expressing in form of the ranks, so who is more beautiful, who is less beautiful? So in that case, you also can use the non-parametric test. And samples is not normally distributed, already I have discussed, because it is skewed data. If some data is skewed, it cannot be normally distributed. So it is opposite to each other. So when data is skewed, it cannot be normally distributed. If normally distributed, it cannot be skewed. So the distribution lies under the normal curve. But this is the very important feature, though it is the non-parametric test. So if the sample is not normally distributed, but the distribution lies under the normal curve. And it's assumption free. The observations need not be independent of each other. Need not be independent. Maybe dependent. So that's the assumption free as well. And the economical in time. So it takes much less time. That means not more time we will take. And median is the measure of central tendency that is used here, and it is less likely to be influenced by the outliers in the data. That means there is outliers and it will be influenced by that, and less precise and have less power than the parametric test. So it is less precise and less power, because parametric test has the more power. So that is in if we will see the precise, then it is greater compared to the parametric test. But if will not going for the precise thing, then you can go for parametric. And the compare samples to make inferences or test to significance or trustworthiness of the quantitative statistics. So compare samples also it can be taken. So now, after knowing the features and assumptions of the non-parametric test, now the next thing is that how we will find the assumptions of parametric test, and the next part is the assumptions of parametric. How we will judge the parametric test. That means the reverse of the non-parametric test. We will find the parametric test. So first condition is that the normal distributions already we have, and there is some assumptions, and here we can find the interval or ratio scales. So that is the important one. So out of 4 scales, only 2 scales we can use it, either interval scale or ratio scale. So these 2 scale we can use under the parametric test. So please remember this thing, that 2 type of scale is important, are important under the parametric test. And all OLS properties, ordinary least square properties, will be hold good here in this parametric test. But OLS properties cannot be hold good in the non-parametric statistics. So these are the important things. And now you see parametric test is based on the types of scale used for measuring the data. Parametric tests are used only with the data based upon the ratio or interval. Already I told you that this ratio and then interval, and a few outliers in the data. So in the data also you can find some few outliers, and outliers can be described as extreme values in data distribution. So these are the gist of the parametric test. So how you will identify the parametric test, and how you will identify the non-parametric test. That hint I have given. So now we have to proceed to our main lecture, that means first lecture and first point of the lecture, that is our choosing the right statistical test. So now let me zoom in, because it is very uh, small to see. So now I am zooming it. So now we can see it. So now how to choose a statistical test. So now under this I have divided.
Excuse me, sir.
Yes.
Can we put it on full screen so we can get a bigger? Prints are very small. Can't see the print. Thank you, sir.
Sir, I think it is very difficult to show in this platform. So you just, I have already shared in this All India Research Scholar group so they can directly look at it. Otherwise, we can, after the class, we can share it.
Thank you, sir. Please continue, sir. Please continue.
Mohanty sir, are you there? Mohanty sir, are you there? I think just give 1 second. Sir is, I think, some network issue there. Uh, just give 1 second. I am not talking about the PPT. What sir is showing, where you use the different statistics, the slide only. I have shared in this All India Research Scholar group. So I will once again, I am just sharing this. Prasun, if possible, you just share the slide now, sir is showing in this WhatsApp group. Mohanty sir, are you there?
Sir, please unmute yourself. You are on mute.
Yeah, you are talking me or Mohanty sir?
No, sir, Akshay sir.
Gayatri, you just, Mohanty sir is there, Gayatri?
Yes, sir.
Mohanty sir is there in this group now?
Let me
Mohanty
check.
sir, just
Yes,
check.
sir,
Yes,
he is
sir,
there, sir.
he is there, but his mic is mute.
Just tell Mohanty sir, you just unmute yourself. I'm not able to see. Mohanty sir, you just unmute yourself.
Mohanty sir, you are on mute. Please unmute yourself.
It's are speaking.
Sir, we can see the PPT, but unable
Yes,
to hear.
yes,
Yes.
but voice is not coming.
He's still in unmute.
Oh, just give me 1 second.
Sir, please click on the middle button. That is the audio button. Mohanty sir.
You are speaking the phone. Sir is there. Mohanty sir, are you there? Please unmute yourself and speak.
Yes, sir. You can also text message if you have any technical glitches.
Yeah, I'm making call, but he is not taking.
Yes, yes. Yes, is it audible?
Yes,
Yes,
sir.
sir.
Yes, sir. Yeah, now since yes.
It's network problem, sir. Your network problem is
Yeah,
there.
I understand. I understand.
Anyhow. So
Yeah.
now, is it visible now?
I think you just share your page.
Just a minute. Just a minute. Just a minute. Because this internet problem is there.
Yeah, but I
Yes.
understand.
Now is it visible? I think it is visible.
Yes, coming, sir. Coming.
Yes.
Yeah,
So now
sir.
you see. So already we have seen that now here how to choose a statistical test. The first one is the dependent variable or the outcomes, because the other name of the dependent variable is our outcome. And now this outcome variable, we are taking it in form of the continuous dependent variable. So now if our dependent variable is in the continuous format, so what type of options and what type of statistical data or statistical test we can use? So first of all, from the left to right, we'll go one by one. So first of all, this is the continuous dependent variable. So if our dependent variable is continuous, then we can see that whether it may be one continuous with this continuous independent variable, because we know the dependent variable is the function of independent variables. So we will form in this way. That means the y is the function of x. That means dependent variable is the function of the independent variable. So if that functional format will come, then we can think of the statistical test. So in that way, now I am deriving. So now this is the dependent variable, and now I am assuming my dependent variable is in the continuous format, and that is the function of many types of independent variables. So what may be the independent variable? So now this is my independent variable or the predictor variable. So now all are my independent variables. Now you see this row. So now in this row, the first row, I am telling that one continuous independent variable. Let us say my continuous dependent variable is there, and it is the function of one continuous independent variable. So if it is so, what type of statistical test we will use? So there are two options. The first option, first of all, we will go for assessing a relationship. Whether we are going for assessing the relationship between the continuous dependent variable and one continuous independent variable, because already I have taken one continuous, not more than one. That means it is simple. That means it is a simple one. So now if it is the assessment of the relationship, then we have two options. Either you can use the parametric test approach or the non-parametric test approach if our main aim is to assessing the relationship. That means what is the relationship between the dependent variable and the independent variable. So if it is the thing, then we have two options. So already I told when the parametric test will be used, when the non-parametric test will be used. Already I have given you the hint in form of the assumptions. So based upon the assumptions, now we have to take, let us say our wish is to go for the parametric test. That means the data is normally distributed. That is confirmed one. So that is the main important thing and important thing. So now under this parametric test, we can go for the Pearson's correlation coefficient. Small r, that is Karl Pearson's coefficient, we can use it. So that Karl Pearson coefficient shows the relationship between the dependent variable and the independent. For example, I am telling, let us say r value, that small r value is 0.7. That means there is a 70% relationship between the independent variable and the dependent variable. So in that way we can assess. So that's the parametric test. So now if our data is in form of the non-parametric approach, so what we'll do? We have to go for the Spearman's rank correlation test. So same correlation. It is also correlation. It is also correlation. Well, correlation will show you the assessment. And from that assessment, two types of correlation approaches there. One is parametric approach and another is the non-parametric approach. And this is the rank approach. So in this way, both the parametric and non-parametric approach you can use based upon your availability of the data. Whether data is touching the parametric or the non-parametric. Based upon that, you can change your approach and you can fit it to your thesis. You can fit it to your dissertation. You can fit it to your work. So it is all about the one dependent variable and one dependent variable with a continuous mode. So now it is the assessment only. So now second option, after the assessment, now we want to predict it. We want to forecast it. Prediction of the dependent variable. Which dependent variable? It's continuous dependent variable. We want to predict it. We want to forecast it. So when we go for the forecasting approach, there are two things. One may be simple linear regression. Why? Because there is only two variables. One is dependent variable, one is independent variable. So as per the rule, it is simple linear regression approach. That means y is the function of x. So it will give you the simple linear regression approach. And after that, you can predict the parameter and predict the value. Then check for residuals for normality. So then the whatever residuals are there under the simple linear regression, that we have to check for the residuals. That we have to check for the normality. So if it is confirmed, then we can take it as granted. We can fit the one dependent and one independent, and in that way we can find the three types of tests. One is parametric, and also simple linear regression is coming under parametric test. Why? Because there is a normality, there is OLS, that means there is a normality. So simple linear regression approach is also the parametric, but only for the assessment only you can go for the non-parametric as experiments formulation to this. So now come to the next situation. Let us say one dependent variable is there, and with one dependent variable, let us say two or more continuous independent variables are there. So in that case, we can say the dependent variable is the function of a two or more independent variables. So in that case, we can go for the multiple regression analysis, which is also coming under the parametric approach. Why? Because there is the chance of the normal distribution, because without that we cannot go for this multiple regression and simple linear regression approach. So this multiple linear regression approach is also touching the normality approach. So that means as it touches the normality approach, it relates to the parametric approach. So in this case also parametric test you can use. Then third one, this is the first one, this is the second one, and the third case. So one dependent variable is there, with one dependent variable with a continuous code. So now let us say one categorical independent variable. Categorical, that means there is nominal. Maybe the independent variable is in form of, let us say, sex. Sex is male and female. So like that, let us say education, the types of education from starting from the primary, secondary, then higher, and these are the categories. So 1, 2, 3 category you can make it by the numerical numbers. So if one categorically independent variable is there, so let us say one sex category is there, that means male and female, that means two options are there. So in that case, what will be the option? So there are two options. So first one, that one categorically independent variable would be comparing, that means comparing independent unmatched groups. This is one. Comparing independent unmatched. That means they are not matched. So there are two groups, they are not matching with each other. That means this is unmatched. And we have to compare that independent unmatched groups. So this is one. So now if this case is coming, then we have also two options. What options? Maybe two groups, maybe more than two groups. These two conditions will be coming. There is no third conditions. So if it is compared with the independent with the unmatched group with the two groups case, then there are two possibilities. You may use the parametric test. Already I told you the parametric test means definitely there will be the normal distribution. Okay, that is common. Anyhow, that should be touching for the parametric. So now in the parametric independent sample t test you can use it. That's t test. Already I told you the t test, z test, and f test. They are coming under the parametric test. Already I told you the assumptions part and introduction part. So now here you can use only the independent sample t test if the two groups are there and it is unmatched, and if it is a categorical in nature with respect to the independent. So now let us say the normal distribution is not found. So what you will do? The same categorical independent variable is there. So now your option is to choose the non-parametric test because normality is not touched. So for that reason, which test we will use? We will use the Mann-Whitney test. Mann-Whitney test. So you have two options. If you will choose the parametric having the normality of data, then you can go for the independent sample test. And if it is not having the normality, then you can use the Mann-Whitney. So now it is on the two. So now come to the more than three groups or more than two groups. So if more than two groups will be there, also there are two options. You can go for the parametric test And in this parametric test, you cannot use the independent sample test, because independent sample test and one-way ANOVA is something different. So now here you have to use the one-way ANOVA test if more than two. And if it is non-parametric, then you can go for the Kruskal-Wallis test. So now you have the four options: 1, 2, 3, 4, and these four options will be chosen based upon the two basic divisions, whether it is two groups or whether it is more than two groups. Then after you see whether this assumption is fitted or not. If this assumption is not fitted, then you cannot go for this one. So now, if this assumption is not fitted, which is the alternative assumption can come with one categorical independent variable? Yes. It may be repeated measures. That means the same thing can be repeated more than one time. That means more than one continuous observations per subject. That means it is repeated. That means it is happening, frequently happening. It is often happening. So also in this case, two subgroups will be there. One is two groups case, another is the more than two groups case, just like the previous time. So you have to check whether two group is there or whether more than two groups is there. If more than two groups or two groups are there, check the main assumptions, whether it is empirically independent unmatched group or it is the repeated measure. The important thing is you check the repeated measures thing and the unmatched group thing. So this will give you the guidance. So if it is repeated measures, then you check how many groups you have under your hand, in your hand, and how many groups are there under the unmatched group. So in that way, excuse me, you can find out the test. So now come to this repeated measure case. So under the repeated measure case, we can have the two options here also. The parametric paired test. If it is parametric, means normal distribution will be achieved. And here the paired t-test. Now you see here it is paired t-test and here it is independent sample test. So this is the main difference. If it is repeated, it is paired t-test. If it is not repeated, means unmatched, it is independent sample t-test. So this is the main difference for with respect to the parametric test. But in both the cases, the normality is attained. Normality of data is attained. So now if the data is not normally distributed, so definitely you have to choose the non-parametric test. So under that non-parametric test, you have to here use Wilcoxon signed rank test, not the Mann-Whitney test, because Mann-Whitney test will be utilized only when there is unmatched groups. Be careful. And if it is repeated measure cases under the two groups, then you can use Wilcoxon signed rank test. And the details you can go from your statistical things, because how the Wilcoxon signed rank test will be measured, that is your things, because here we are confined to show you how and where and when the test will be utilized. So how to calculate the Wilcoxon signed rank test and how to do the Mann-Whitney test, that is your lookout, because it is not on the this coverage. So now we will go for the next one. Now you see if it is more than two, now you can see the parametric. If it is repeated, that will be more than two. If it is parametric, then repeated measure ANOVA. Now you see here it is one-way ANOVA and it is repeated measures ANOVA. So there is difference. This is one way and this is repeated. So this is the main difference, one way and repeated. ANOVA is common. Now you see here analysis of variance we are using. Also here analysis of variance we are using. But here the extra thing we are using, that is repeated measures, and this is one way. And here the condition also, the data should be normally distributed. Then after we can use this one. So if the data is not normally distributed, let us say that means should you skip your project? No, you have the alternative. So now alternative is non-parametric test, and in this case, Feynman test you have to use. So now you see the previously we used Kruskal-Wallis test. Now we are using Feynman test. So now this is the main differences. If you will judge this first box, second box, third box, and fourth box, you will get the complete idea how the tests are differing from case to case and from base to base. So in that way, you can judge the tests and you can use the test for your project. So you should not be frustrated. So if a parametric test is not utilized, no problem. Just check it whether non-parametric test will come up or not. So accordingly, you can manage your project. So you should not leave the project at anywhere. You should not be frustrated enough because option is there. So now, next one is the two or more categorically independent variables. Because we have till now we have seen that one independent categorical variable. So now, if more than two categorical independent variable will be there, let us say one is independent variable is sex in the category and another is education category. So now two categories are coming. That means under the sex, male and female are coming, and under the education also, that is also categorical. Maybe three subcategories will be coming. So in that way, we are finding the two minimum two categorical independent variables. You can take more than that. If this is the case, then you have the option 1, 2, 3, 4 options. So now you can use the factorial ANOVA. One option is there, or the factorial repeated measures ANOVA. You can use it, or the multiple regression analysis. You can use it. What we are using here, and or the factorial mixed ANOVA you can use. So these are the four different techniques or tests you can use if the categorical independent variables number will be 2 or more with one continuous dependent. Then the towards the last, if it is 2 or more categorical and continuous variables. So now it is interesting one now you see. Here, these categorical independent variable will be there. That means 2 or more categorical. That means sex and education is there as the independent variable. Along with that, one continuous variable, continuous independent variable is there. That means here maybe at least 3 independent variables are there, and a 2 independent variable in form of the categorical way, and one independent variable is in the continuous way, isn't it? So what we have seen here, one continuous independent variable. So if this type of a mixture will be there, then either of these tools you can use. So now your option is multiple regression or ANCOVA you have to use. So these two options is left with you. Either you go for multiple regression analysis and ANCOVA. And these two are purely coming under the parametric test. It is not under the non-parametric test because in both the cases the normality will be attained. So for that reason, you can have some sort of idea on the choosing of the statistical tests. So now come to the down part. Now you see, let us say categorical dependent variable is there. So now it is categorical dependent variable and categorical independent variable, the function of this. So when categorical dependent variable, that means categorical dependent, let us say I'm telling y, the sex, y1 and 0, that means male and female. There is categorical dependent variable. It is the function of a categorically independent variable. Let us say sex is the function of, let us say, education. So now education is the independent variable. So now this is the sex is the dependent and education is the independent. So if it is like this, then both are the categorical, means dependent and independent variable. Then we have two options. Either we can use the confidence table by using the chi-square test, or we can use 2 cross 2 table or Fisher's exact test. So these two options are left with us. So if both are categorical in nature, both the dependent variable and the independent variable are in the categorical nature, and if it is in the non-parametric way, then you can use this either chi-square test or the Fisher's exact test we can use. So now, if the categorical dependent variable and two outcomes are there, that means here only two outcomes are there, and prediction of the dependent variable, and if it is the question of the prediction, that means prediction or the estimation, because prediction will come from the estimation side. Once you will estimate, then you can predict. Vice versa cannot be possible. So first of all, you have to estimate. Then after, you have to go for the prediction. So when the prediction case will come up for the dependent variable, then it is better to use the logistic regression. So now when the logistic regression will come up, it is related to the parametric test. It is completely non-parametric test. It is completely parametric test. So now in this way, based upon the cases, you can go for either the parametric test or the non-parametric test. So this is one way of dealing. So this is one school of thought. So now let me talk to another slide so that you can get some sort of detailed idea. Now you see. So we have to go to the deeper. Now selection of appropriate statistical test. So how we will find the appropriate test. So now you see, I have shown you here the different approach. So in the previous slide, I show you one approach, and I didn't talk about RI and O and N. What is RI? RI means it is ratio and it is interval. O is ordinal and N is nominal. So I have quoted it. So now with these scales of data, how we will form? So that is another technique. So previous slide was the one of the techniques, and this slide is another technique with respect to the scales of data. Already I told you four scales are there for the data sets. One is ratio scale, one is interval scale, one is the ordinal scale, another is the nominal scale or categorical scale. If these four types of scales of data will be there, let's say, how we will prefer and how we will choose the tests. So that is important thing. That also you have to know it. Not only that based upon the variables, whether it is continuous variable or the categorical variable, but beyond that also some other category or some other skills are there. So if that skills will be there, so generally what type of test we can use it. Now come to the point. So now you see description of one. So if it is one group, let us say only one group is there. So now under one group, we may have four types of skills. Means that group, if that group is coming under the ratio scale and the interval scale. Let us say data is having the ratio scale or the interval scale. So we have two options. Now you see. Either we can use ND. ND means normal distribution. This is the normal distribution approach now, isn't it? And zero means ordinal, or else now you see, if it is these two, there are two options will be there. One, either you can use the normal distribution or non-normal distribution, NND. Maybe it is normally distributed, maybe it is not normally distributed. Two options will be there. So if it is normally distributed, that means it is parametric. That means here you can either use the mean and standard deviations. Mean or the standard deviation. Mean is the part of central of measures of central tendency, and SD standard deviation is the measures of dispersion. So both measure of central tendency and measures of dispersion you can use if the data is touching the normal distribution and data scale will be in form of the ratio and the interval. So this is one thing. So now if it is not normally distributed, so now you have option. Either you can use the median approach, or you can use the interquartile approach, or you can use the range approach if data is in the ordinal. Are you getting me? So this test you can use it either median or interquartile or range if non-normal distribution. So now three scales are over under one group. Description of one. So now what is left? The left is the N, means categorical or the nominal data set. If that one group is having the categorical data or the nominal data set, you can go for the proportions. Proportion technique, you can use it here. That's it. So now this is all about now the one case. So now we'll go for the comparison of one group to a hypothetical variable. comparison of one group to a hypothetical value. That means here also scale cannot be changing. Only same four scales are there: RI, O, and A. RI means it is one category, it is second category, it is third category. So now in the RI category, we have also two. One is normal distribution, another is non-normal distribution. So if the comparison of one group to a hypothetical value condition is applied, and this condition is giving you the data in form of the ratio and interval scale, and it is approaching with the normal distribution, that means it is parametric. It is confirmed. So now it is parametric means now one sample test. Already I told you in the previous slide. Now same with the in the different way I am explaining it how the one sample test will come with some sort of series. So now non-normal distribution, that means Wilcoxon test. Already I discussed that part in the previous slide. So now it is little bit elaboration, and we are going to the deeper part because research is going for the deeper part. It is not the overview. It should be the deeper. So now the RI part is finished with the comparison of one group to a hypothetical value. So now if data is in form of the ordinal scale, then if it is ordinal scale also you will use the Wilcoxon test because it is non-normal distribution. So same you have to use it. And if data is in the categorical format, means the nominal form, you have to go for the chi-square or binomial test. So chi-square test is otherwise known as the binomial test because only two options are there, either yes or no. That is binomial, either yes or no. So that is binomial, and chi-square, that is the independent test. So now in this way, if the data is in the categorical format or scale, you can have this type of test. So now come to the next part, the comparison of two groups. Means up to this we are with the one group case. So now we are taking more than one comparison of two groups. Previous slide also I told you one group and two groups. So now and more than two groups also I told, and I am now telling in the different way with the default part. So now in the comparison of the two groups. So now if two groups are there, so these two groups may be on pair, may be paired. Means on paired means unmatched. They are not matched, they are on paired. Means unmatched. Paired means matched. This is the way you have to deal. Paired means matched, and unpaired means unmatched. So in this way, because in the last slide, in the previous slide, I told you unmatched and matched. So now this is unmatched groups. So if it is an unmatched group, so same thing will happen. Why? Same thing means same four scales, because there is no such five scale. Only four scales are there. Variables are four scales: RI, O, and N. Because RI every time in one block. So that's why I'm putting in one block. RI. So if it is RI, two options will be there. And here in the unpaired groups, if RI is there, it will be normal distribution. And that normal distribution will give you unpaired t-test. Now you see, this is unpaired. T-test will be there, but it is unpaired. And as you know, t-test is belonging to the normal distribution. So this is parametric. This is parametric because normal distribution is closed. So definitely it is the parametric approach. And now come to the ordinal approach, or that means ordinal scale. If data is in form of ordinal, then non-normal distribution. So now if it is the non-normal distribution, so this non-normal distribution can be achieved either for the ordinal data, or this is the ratio data or the interval. If data is under these three categories or scales, there is also chance for choosing the non-normal distribution. That means if these three types of data are touching the non-normal distribution, then only you have one option. Is the option Option is man-Whitney test. Already in the last slide, I told you man-Whitney test. So now this man-Whitney test, you will be. So in the last slide, I didn't touch this thing. So I am touching in different way with the different cases. So now this is good. So now if it is categorical data with on-paired groups, so now you will go for the Fisher's test. Already last time in the last slide I told you the Fisher's test, or you can use the chi-square for large samples. And remember one thing: this Fisher's exact test and the chi-square for large samples, and here there is some sort of similarity. Later on I will discuss on this. So now if data is in the categorical scale, only you have the option, either you have to go for the Fisher's exact test, or you can go for the chi-square for large sample test. So this is all about the on-paired groups under the comparison of two groups. So now under the same two groups, so if the groups are paired, if groups are matched, so what will be happening? So now directly here we are done. Already same four scales are there, Ri is there, O is there, and N is there. And Ri, it is every time in one block. And that will give you two options, maybe normal distribution, maybe non-normal distribution. So if the scale is in the Ri with normal distribution, definitely parametric test will come in form of the paired t-test. You see, this is paired t-test. This is on-paired t-test. This is paired t-test because it is paired. Because it is unpaired. That's why it is unpaired t-test. As it is paired, it is paired t-test. So now this is coming. So now if the data is not normally distributed, so now you have to go for the Wilcoxon test. What will be it here? Wilcoxon test. You see here. See the comparison. This one, the same test you have to. So from this it is concluded that this is a non-parametric test. This is a parametric test. This is a non-parametric. So ultimately, we are confirming that this is parametric test. This is non-parametric test based upon our scales of data, based upon our groups, isn't it? So now we have to go for the paired groups under the ordinal data set. If data is in the ordinal scale and if the groups are in the paired, then you have the option of same the Wilcoxon test. No such other. That means Wilcoxon test can be used either for ratio or the interval or the ordinal scales of data. So in these three scales of data, you have the option to choose the Wilcoxon test. But when you choose this one, you have to see whether it is paired groups or not. If it is paired groups, then which type of a pair? Whether it is under the ordinal data set or it is under the ratio or interval data set. That you know. And it should not be the categorical scale. So if it is categorical scale, Wilcoxon test cannot be applied here. Though it is the non-parametric test, because there are various non-parametric tests available in the market. So now the last part is left, the numerical, that means categorical, and under the categorical with paired groups, McNemar's test you can use. This test you can. So now that means this is also coming under the non-parametric test. This is not parametric test, isn't it? Because now one thing is confirmed. So if you want to know whether you will use the parametric test or non-parametric test, simple rule of thumb I am telling you. The simple rule of thumb is, if data is in form of Ri format, either R or I format, there is a more chance of getting the parametric test. But in other two cases, ordinal case and categorical case, you cannot find the parametric approach. So that you have to remember with respect to the scales. So if some question will come, let us say some scale will be given to you, and people will, and your teacher will ask you, please tell me from the scales of data, which test will be utilized, whether the parametric test or non-parametric test. Simple answer from your side is that if Ri is there, there is a chance of getting the parametric test. Also, there is chance of non-parametric test. Already we have seen it here. Already we have seen it here. Here it is the parametric test. Here it is also the non-parametric test. In the same cases, here also the same. So there is a chance, but more chance are there for the Ri. But in case of ordinal data and the numerical data or categorical data, there is little chance of getting parametric test. So it is confirmed that non-parametric test will come if the ordinal and numerical data or nominal data will come up in the field. That you want to remember. So this is the conclusion from this slide. Also, we will see in the rest part of this slide the same thing whatever I told you. So now this is finished. So now we have to go for next one, comparison of 3 or more groups. What we discussed in the previous slide, because 2 groups we have taken, single group we have taken, more than 2 groups or 3 groups we have taken. So now comparison of 3 or more groups now. So now in the previous slide, we did not take comparison of 3 or more. We stopped it here, comparison of 2 groups or more than 2 groups. In the previous slide, we stopped here. But now in this slide, this is the extra thing we are going to discuss. Now comparison of 3 or more groups. So let us say if 3 or more groups will be there. So what will be the things? So similar. There will be paired thing, there will be unpaired thing. That means unpaired groups here, it is unpaired group, here it is unpaired group, here it is matched group. Matched means paired. Matched means other name of the match is paired. So now if it is unpaired groups with more than 3 or 3 or more than groups with unpaired weight, the simple thing will come up. So now first of all, it will come, here you see, Ri, O, and what I told, in the case of Ri, there is chance of getting the parametric test if normal distribution is coming. So now come to the point. So now with unpaired with R and I. R and I, normal distribution is achieved. Normal distribution achieved means close your eye, just you think by parametric test is coming. No doubt about it. And what type of parametric test? This is one way ANOVA, analysis of variance. So this is also the parametric test. Suppose normal distribution is not achieved under the unpaired groups with at least 3 or more than groups, and non-distribution, non-normal distribution is coming up. So under the Ri set, and you have the option for choosing the Kruskal-Wallis test, what I discussed in the previous slide. So you can draw the conclusion from that as well. So now this is the thing. So now we'll go for other 2 scales. If the scale is in the ordinal, if the scale is in nominal. So if it is the ordinal scale, also same test you can use, Kruskal-Wallis. That means Kruskal-Wallis test will be utilized if the scale of data will be in form of ratio, interval, or the ordinal. If a data set is in form of 3, you have the option to choose the Kruskal-Wallis test. But thing is that this Kruskal-Wallis test is a non-parametric test because normal distribution is not achieved, and it is under the unpaired groups with 3 or more than groups. Clear? So now we'll come to the nominal data set. Nominal data set or the categorical data set with unpaired groups with 3 or more than groups. So now the chi-square test you can, and simply we are calling the chi-square test as the independent test. So independent test, otherwise known as independent test. So it is also the non-parametric test. So at the end we are concluding whether we are using the parametric test or non-parametric test with respect to the scales of the data. There are 4 scales: Ri, O and N. And with respect to that, we are thinking whether it is one group, whether it is two group, whether it is three or more groups, isn't it? So we are doing, and with the paired and on-paired. So now the on-paired is finished. So now with the matched one, that means paired one. So same thing, Ri, O and N. So if it is Ri, I told definitely it will be having some sort of the normal distribution and non-normal distribution. So if it is normal distribution, the repeated measures ANOVA it will come. So it is a parametric test. Because normal distribution is a 0. So now here it is non-normal distribution. If it is non-normal distribution having the ratio and interval, then Friedman test we can use it. And same Friedman test we can use for the ordinal data set, isn't it? So now the option is there. Friedman test you can use in two cases. Either it may be in the ordinal data set or it may be in the ratio or interval data set, scale state. So if it is ratio and interval, it must touch the non-normal distribution. Then you can use the Friedman tests. So now the next part, the last part of this matched one is the nominal data set. So if it is the nominal or categorical data set, then you can use none other than the Cochrane Q test. This test you can use for this matched comparison 3 or more groups. So now the last part of this slide is the not last part, another last two parts, the measures of association. So now up to this we have seen one group, two group, more than three or three groups, at least three groups. So now we will go for the major association between two groups. Association means relationship. Just like in the previous slide, we saw some sort of a correlation coefficient, measures of association, isn't it? Our test we have seen it. So now under this measures association between two groups, if two groups are there, where how we will find the association measurement. So now come to the point. Same. First of all, you see whatever data you have collected, whether that data set is either under the Ri block or O block or N block. If it is Ri block, same formula we have to use. It might be under the normal distribution, it might be under the non-normal distribution. So if it is under the normal distribution, you can use the Pearson correlation coefficient, what I discussed in the previous slide. So now it is also same thing is coming in different way. Means in this slide we are taking the help of the scales of data. Previously, in the previous slide, we were using the variable side. Now we are using the scale side. So from the scale side you can decide, from the variable side also you can decide. So there are different things. So based upon that you can decide as per the rules and regulations. So now this is control. So now if non-normal distribution will be there, what will be done? If association is related, so then you have to go for the Spearman's correlation coefficient. Already I discussed in the previous slide. So previous slide I didn't talk about these scales. I talked about only variables. Now I am talking about the scales. So this is the main difference between the previous slide and this slide. So now we have to go for the ordinal scale. If it is the ordinal scale, so now in under the ordinal scale also there is a chance of getting the Pearson correlation coefficient. But actually it should not be like that. If it is ordinal, it should be the Spearman correlation, because this is called as rank correlation, because ordinal approach is under the rank. This is a rank approach. Ordinal approach is a rank approach. Yes. Now you can put the question that why it is coming under Pearson correlation. So now sometime what we are doing, though the data is in the form of the ordinal approach, so we are putting in form of some numbers. Either we are converting in form of the interval or we are converting in form of the ratio. So if it is converted in that way, mind it, then Pearson correlation coefficient can be possible, or else in the layman way, if data is ordinal, we should not prefer this one. We should prefer Spearman's correlation coefficient. So these things you have to remember. So how and when you have to use it. So specifically, if rank is concerned, definitely rank is related to the ordinal approach. So definitely Spearman correlation coefficient is much more preferable than the Carl Pearson's correlation coefficient. But if this ordinal approach is converted to this way, then Pearson is preferable. So you have to see your data and you have to see your approach, the way you are doing. So in that way, there will be little bit confusion whether you will use this one or use this one. So how you are interpreting your scales of data. So that matters a lot here. So now the last part of this is means under this the nominal data. So in the nominal data, under the nominal with association, that means this association contingency coefficients. So either you have to use the contingency coefficient text. So this is all about the measures of association. So now under the prediction approach. So now we have to go prediction approach, the last part of this slide. What is the prediction? So now you can ask me, sir, why there is prediction? Because you see, up to this major association between two groups, we are in the estimation process. We are in the estimation process. So estimation is not the final thing. Why we are going for the regression? Why we are going for the estimation? Because we have to know the future thing. We have to predict. We have to forecast. So if something you are generating, if you are not contributing something to the future, what is the use of your analysis? So for that reason, prediction is a very, very important one after doing the estimation part, after doing the estimated result. So up to this, our estimated thing is over. This is 1, 2, 3, 4, 5. Up to this, we finished our estimation part. So now we have to go for the prediction. So let us say you will be one of the advisor for the policy for the government. Let us say. So government definitely will ask down to 5 years what will happen. Though you know all the techniques, if you run the things in the software and you find out some sort of result and you are showing so blah 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 blah. But at the end of the day, the government will ask you, as you are the consultant for him or advisor to him, he will ask you or she will ask you, hey, leave all the things. I don't have any mind to judge it. You tell me down the 5 years what will be the things happening. That time you have to tell. That means this last part will come only when you do your estimation part properly, after observing proper scales and proper use of the variables. These two are very important things to judge the parametric test and non-parametric test. Be careful. Scale is important as well as the type of variable is important. So both are important, not only one, both at the side by side. So now the prediction, that is forecasting. You can say in that way, and that will come from the estimation. So now this has two dimensions. From another measured variables and from several measured or binomial variables. Two options are there to do the prediction. One is from another measured variables. Some other measured variables will be there. So from that, either you can get some sort of a prediction, or some several measures are there, or some binomial variables are there. Binomial variable means dichotomy variable. Yes or no, right or wrong, that is binary, isn't it? So either this or this. So now take the first. Let us say you are taking from the other measured variables. Same thing, because we are dealing with the scales of data. So 4 scales are there. Already I told you the RI scale is under one block every time. They will be just like you can say the husband wife, they will be couple like this. So these scales are called as the couple scale. Couple scale. They cannot be, they cannot be different from each other. Whenever R will go, I will go. I will go, R will go. Either or. So they will be forming in one block. So that's why we are calling it as the husband-wife block. So they will not be separated. Either this will come or this will. Because sometimes husband may represent, sometimes on behalf of husband, the wife may represent. So in that way, it can be, or both can be possible. Both husband and wife can meet the meeting. So in that way, it is in one block. So now this is one block under this criteria. So also same thing will be coming. One is normal distribution, another is a non-normal distribution. So two criteria are there to judge the parametric and non-parametric. So now if it is a normal distribution approach under the RI block, so now it is simple linear regression. What I discussed in the previous slide, simple linear regression analysis, we have to use it if it touches the normal distribution. And if it is not normal distribution, then it is non-parametric test that we have to see it. Now, if it is also the ordinal approach, the ordinal approach means it will touch the non-normal distribution and also this normal distribution. And if it is the numerical data set, so now you come to this ordinal. Now it is if it is a numerical data set, so now we have to see here. Now it is a simple logistic regression. If it is categorical data, if it is categorical data, simple logistic regression, and it is also the parametric test. It's not a normal. So now you may be asking the question, sir. Till now you are telling if the data is normally distributed, there will be parametric test. But now the simple logistic and here it is nominal data set is there. And nominal data set never approaches the normal distribution. So how the simple logistic regression will come under the normal distribution? Now see the answer. The first of all, in the history of regression, the probit model and the probit model came then after logit model came. And in the logit model, there is a CDF function, cumulative distributive function, CDF. But in the probit function, there is a normal distribution. That means the data set is approaching towards the normality. But here in the CDF, though they are not approaching the normal distribution, but they are close to the normal distribution. So for that reason, as we are discussing in the social science platform today, we cannot go for the probit analysis. Why? Because the probit regression analysis will be used for the computational science, maybe physics, chemistry, biology, because the exact result will come out. They will follow the normality. But in the social science, it is difficult to have the normality. So that's why later on, all the social scientists are moving to the logistic approach, not the probit approach. So for that reason, we are considering that logistic approach is under the parametric because it is close to the normal distribution. Though it is not exactly normal distribution, but it is close to normal distribution. If you will see, if you put the data, same data, that means the same numerical data in your data set or in the SPSS set or in the eView set, and if you run the logic regression and if you run the probit regression, almost similar result you will get with little bit differences. So no such huge differences are there. So the thing is that the wing you are belonging, that means we are belonging to the social science. That means we have to use the logit model. If we are going for, or if we are in the uh, non-social science, means the physical science department, definitely we should go for the probate. So for that reason, here it is the exception. You should not blame me, sir. Every time you are telling if normal distribution will be there will be parametric test. But here it is the nominal data. Nowhere we have found that nominal data will lead to the normality. That's true. But the concept is here, this nominal data set is approaching to the logistic model, and already I told you the logic model is approaching towards the normality, though it is not exactly normality. So that's why we are assuming that logistic regression is under the parametric, not on the non-parametric test. I think it becomes clear for you. So this is only the exception. So in that way, you have to analyze here in this. So now we have to go the next one. The prediction, because this is the prediction we are doing. And next prediction, the last prediction. In the last prediction, you see from several measured or binomial values. Here we have not taken the nominal data set, because nominal data set here we have taken, and here the nominal cannot come. Sorry, ordinal cannot come. So now here that from several measured or binomial variables, one block is there. This is common block. Already I told you it cannot be separated from each other, and this is the nominal. And nominal means it is categorical. And if it is categorical, let us say for example, if it is Ri block, if it is Ri block, we can use the multiple linear regression or multiple non-linear regression. We can use it. So if data is in form of the non-linear trend, so you can use the non-linear approach. So let us say if it is the log format. So if your data set is in form of log, so log will take the non-linear. If there is no such log, that means if it is the linear mode, that means the degree is 1. That means linear approach. That means multiple linear regression will be utilized. So when the multiple non-linear you will use. So if data is not in the linear form, that means the highest power should not be 1. Highest power should be more than 1. 1.5, 1.2, 2 like this. So if like that, then that will take the shape of multiple non-linear regression. For example, the common example is if it is a log equation, log equation, or semi-log equation, or log-lin equation, or lin-log equation. So that is also the multiple non-linear regression analysis. So in that case, also you can go for the prediction key, isn't it? And for example, let us say if it is not R and I block, and data is in form of the categorical, then you have to go for the multiple logistic regression model. That means it is more than one independent variable is there. Now you see here, it is only simple logistic regression means it is only one independent variable. That's why it is simple logistic. And a dependent variable is in the categorical form. But here, the dependent variable is one in the categorical format, but independent variable is more than one. So that's why this is the main difference. Isn't it? This is also nominal. So this is also nominal. This is also nominal. But here it is simple logistic and here it is multiple logistic. Why? Because there are more than one independent variable. And here it is only one independent variable. So this is how we are getting to know how the test, how the parametric test and non-parametric test will be achieved with the consideration of the Ri block, O block or N block, or the with respect to the nature of the variables. So now the next thing, another way of doing the thing. Now third way of dealing whether and of how we will choose the different tests. So now I will ask you here one thing, because here I have not written any parametric test and non-parametric test. Just I want to judge you now here in this slide, and I will ask you, and you people should tell me which your answer should be either parametric or non-parametric. Only you have to tell this way. By saying this flow chart of a commonly used statistical test, I will ask you and you have to tell me whether it is leading to parametric test or non-parametric test. That answer only you have to give me. It is one type of question and answer session from this slide, because already we have made many details in the last two slides. So now you are confident. Are you okay now, all of you? Hello.
Yes, sir.
Yeah. So now this is the question answer session from this slide. Be careful, all are invited. Okay. So I'll be happy if you'll answer it. So now check this flow chart of commonly used statistical tests. So now you see, I have taken the outcome variables, what I did in the first slide. Yes or no? Outcome variables means it is dependent variable. It is obvious. Outcome variable, the other name of the outcome variable is the dependent variable. So now, because we should not go for that, because as you are from the social science department, so it will be a little bit difficult for you people. So we will leave it, isn't it? So last block we will leave it. So now come to the point. So outcome variable, that is the dependent variable, and we have seen in the very first slide that is some sort of continuous variable. There are some sort of categorical variables. That means the dependent variable may be continuous, dependent variable may be categorical. Am I right? Audience,
Yes,
please.
sir.
Okay.
Yes, sir.
So now I am repeating in the same way. I am asking the question one by one, and one person should give one answer. Okay. And if you have given one answer, then you have to give other people to give the answer, and don't tell the answer repeatedly. So if X has given one answer, give the chance to the Y to give another answer. Clear? So don't repeat it. So in that way, we can participate in the large way. So through this slide. So now you see this is the exposure variable. This is the exposure variable. This is the outcome variable. And exposure variable in the previous slides, previous two slides, I told one group may be there, two group may be there, paired may be there, more than two groups may be there, continuous may be there, one group, two group, paired. Like this I discussed in the previous two slides. Am I right? So now this is the another way of presenting my analysis, so that you will be very comfortable to know in what circumstances you will use what type of test. So that's why I'm going to the deeper part of analyzing the things. So now you tell me, this is a continuous variable. First I'm telling the continuous variable with the outcome variable. And continuous, I have taken 1, 2, 3, 4, 5. 5 types of continuous dependent variable I have taken with the exposure variables. First exposure variable is one group, and second one is second two groups. Third one is the paired group, and fourth one is the greater than two groups, and fourth one is the continuous variables. So now you tell me. Now you tell me. So if I will use the one sample t test, which test I have to use it here? Tell me. Parametric or non-parametric? One sample t test.
Can I answer, sir?
Parametric, sir.
Yes, yes. Only one by one, please. If somebody is answering, others should stop it. Please.
Non-parametric.
Huh?
Non-parametric.
Just a minute. Let me open. Let me come to this one. Yes, tell me. Who is telling? Please raise the hand and show me your face in the screen. Show me the face who has answered. Please. Show me your video. Tell me. Come up. Please.
Can I
Show
answer,
your
sir?
face. Show your face with name, please.
I'm Venkatesh.
Yes, Venkatesh Betigiri. Fine. So your answer is what? One
It will
sample
be-
test. What?
Parametric test.
Parametric test. So now, please stop. Now, randomly, just another person, please raise the hand and tell me and show your face and tell me why it is a parametric test. Can you justify? Anybody else, please? Can you justify? Can you justify? Anybody, please? Open with video. Yes, Jai Prakash Singh. Tell me why it is.
Sir, because it is following the normal distribution.
Very fine, absolutely correct. Thank you very much. That means you are attending my lecture very promptly. That's fine. Okay, the
Thank you,
next question comes to the audience is the sign test or sign rank test? Who will ask? Who will tell me? Please open the video. So, show your face, please. Sign test or sign rank test? Which test will be applied here? Either parametric or non-parametric. Only two options are there. Only two options. Tell me. Yes,
The
please.
non-parametric test.
Please show your face. Don't hesitate to show your face. Please show your face. Jyoti Tyagi. Am I right? Am I right, Jyoti Tyagi?
Yes, sir.
Yes. Show your face so that audience will show your face. Yes, Jyoti Tyagi. That's absolutely right. So anybody can tell me why it is non-parametric test? Anybody else, please, from the audience section? Why it is? Please. Yes, who? Please come off. Speak.
Sir,
Already I
because the
discussed.
data is not following normal probability distribution, and it
That
is
means
skewed.
it is Jai Prakash Singh. Show your
Yes, sir.
face. Show your face, dear Jai Prakash Singh. Yes.
Yes,
Oh, I told you should not repeat it, na? Because
Oh,
already
sorry,
you
sir.
have answered, huh?
Sir, I
So
thought you
please,
said from the audience. That's why.
no,
Sorry, sir.
the audience means already I put one condition that those who have told they should refrain from this and they should allow others to tell. And same thing to be repeated, and not it should not be repeated, isn't it? Thank you very much, Jai Prakash Singh, for the second time, but it should not be the second time for anybody else. Now you see, if it is continuous and if it is two group case, then means exposure variable is two groups. And if it is Man-Whitney U-test, usually we are telling Man-Whitney U-test. That is U-test. So please tell me whether it is the parametric test approach or non-parametric test approach, please. Yes, please.
Sir, it's a
Sir,
non-parametric
it is not
approach.
parametric.
Who is telling, please? Two persons are telling. Yes, yes. I appreciate two people's name, please. I want.
Sir, Priya
Gayatri.
Tyagi.
Priya Tyagi. Please show your face, please. Priya Tyagi.
Yes, sir. Yes, sir.
Yes, Priya Tyagi. Absolutely right. So that means you are following me very properly. So one person, another person who is there who told, please, at the same time.
So
Please.
this is Gayatri.
Yes, Gayatri. Please show your face, ma'am.
Yes, sir. Yes, sir.
Yes, Gayatri. So nice answer. That means you are following me very, very deeply. I hope so, and you are enjoying. I hope. Okay. Anyhow, so next is that two samples t-test. Already it is obvious that it is the parametric test. Same thing I did it in the previous two slides. Just I put it in the different way so that you will not be confused. Then next one is the paired. And now the next question to the audience, those who have already answered, they should refrain from this and they should, other people should come up and should tell. And if it is the paired test and if it is coming under the Wilcoxon signed rank test, which test we will use under this?
So paired test parametric, sir.
Paired test parametric. Venkatesh, Banajakshi, C. Ravadigar. Am I right?
Yes, sir.
Okay, absolutely right. So, can you tell me if I will use the Wilcoxon signed rank test, which test it will be?
That will be non-parametric test, sir.
Why?
Wilcoxon signed a rank test, non-parametric, sir.
Why?
Because
the reason?
yes, sir. Because rank is there, sir. That is nominal or ordinal data is there, sir. But in case of parametric, we use interval and ratio, sir. So signed rank means order will be there, sir. Because of that.
Listen me. Even in the case of RI, we have also used the non-parametric in some of the cases. Have you seen it? If it is not normally distributed, so main condition is that non-normal distribution.
Yes, sir. Yes, sir.
That you have to see.
Yes, sir.
That is the perfect answer. Even in some cases of RI, we have used the non-distribution, non-normal distribution. At that time, we are using the non-parametric test. It is not complete that RI will be coming under completely the normal distribution. It is also having the non-normality distribution. So your answer should be like that. So your answer should be pinpointed. That means normal distribution is not approached, it's not addressed. So
Okay, sir.
that is the perfect answer. Clear?
Okay, sir. Okay, sir.
Okay. I think everybody is understanding properly. Thank you very much. So now the next one is the continuous. Continuous means now if I will go for the linear correlation or the linear, Spearman correlation or the linear regression, which uh, which test I will use just as with respect to the Spearman correlation and or the linear regression, the slash I have given you. So which test I have to use? Anybody please? Those who have told they should not tell. The
Sir,
others will
yeah, it should be
tell
non-parametric.
your name. Tell your name. Baisali Pedram.
Yeah,
Okay. Show your
non-parametric.
face, please, ma'am.
Yeah.
Show your face. Open. Yes. So tell me, Spearman correlation slash linear regression.
Non-parametric because the data is non-normally distributed.
Okay. Now my question is, I have put one slash and then I put the linear regression. Am I right? So already we have seen in the linear regression is coming under the parametric test. What is your answer? How you will defend it? Can you tell me?
Once we have established the Spearman correlation, after that we
Yes.
are putting it in a linear regression model. So
absolutely right. That means you got my point, huh? You got my point. That's fine because after the Spearman's correlation, then we are fitting to the linear regression. So that's why it will be non-parametric in nature and normality of data will not be approached. Thank you very much.
Okay.
Thanks a lot. Excuse me. So now, audience, please, anybody, if the Pearson correlation coefficient will come up and slash linear regression, which test? Which type of test will we use? Parametric or non-parametric? Because it is continuous, exposure variable is continuous and outcome variable is also continuous. Both are continuous. Both are continuous. We are inviting, we have set the Pearson correlation coefficient we have to use or the linear regression we have to use. So which test it will be? Yes, please. Anybody? The people should not repeat. Those who have told, please remain silent and give others to say something. Yes, please.
Yes, sir. Yes, sir. This is parametric test, yes, sir.
Parametric
test.
Rajeshwar P. Rajeshwar P, please show your face, please. Every time show your face whenever you are telling so that I will be happy, you know. Okay, Rajeshwar P. So tell me once again your answer, please.
Sir, parametric test, sir.
Okay.
That is correlation and regression, sir. That is normal distribution is there, sir.
Okay, that means Pearson correlation is leading towards the normality. So that's why it is linear regression as well, and also linear regression is covering the normality distribution. Thank you very much. So this is one part already finished. So now you have seen that same thing I have done in the previous two slides. Yes or no? Yes or no?
Yes, sir.
Yes. Only I made one difference. What is the difference? This difference I have made it. The difference is that here I put one exposure variable. Here in the previous two slides, I did not put exposure variable. Am I right? Hello?
Yes, sir. You wrote independent variables.
Third slide is giving you extra knowledge as the exposure variable. Other things remains as it is. So now can you tell me why I have written the skew here? Anybody else please from the audience? Why it is skew I have written? Why I have written skew? Anybody else please? Those who have told, they should not tell. New candidates should raise the voice. Why I have put the skew? Why I have not put normal? Manisha Tomar, tell me. Open your face, show your face. Manisha Tomar. Yes.
Yes, sir.
Show your face. Tell me why I have put the skew here. Tell me.
Sir, because the data is not normal, so
Yes.
either it is a positively skewed or negatively skewed.
Very nice. That means if data is skewed, definitely it will not touch the normality because it is a theoretical knowledge. So either it may be positively skewed or it may be negatively skewed, but data is skewed. So once data is skewed, it never touches the normal distribution, means bell-shaped curve. Normal distribution means bell-shaped curve. Here left side 50%, right side 50%. But skewed data, you cannot find 50% of data. Am I right?
Yes,
Hello? Yes.
Yes.
So that is the thing that you have got from this slide. So now we have to come to the outcome variable with the categorical thing. So now in the categorical, you will see one group, two group, paired, greater than two group, and continuous group, and it is categorical data. Previously, I used the continuous data. Now it is categorical data, and my exposure variable is these one. These are the exposure variables, and outcome variable is the categorical in form. So now, if it is categorical form, now can you tell me this now interesting thing comes off. So now if it is one group with categorical and exposure group is one group, outcome variable is categorical in form, and I am using the chi-square test or exact test. Exact means Fisher's exact test. It's called as Fisher's exact test. Can you tell? Anybody please? Anybody please? Which parametric or non-parametric? Please. Anybody please?
So if I may answer.
Yeah. Vaisali Pedram, already you told, na? Just
Yes.
let others give the chance.
Okay.
If other will not come, then I will allow you. Thank you very much. Next person, please. Anybody? Yes, please. Come off. I think people are sleeping and they are only opening the, I think, this Google Meet, and they are moving here and there. I hope so. Okay, Vaisali Pedram, tell me.
Sir, what I think is categorical data is high probability that it is a skewed data, non-normally distributed. So non-parametric tests will be used most of the time.
Looks like network problem again.
Yes. Just wait for 1 second. I understand there is some network issue.
Yes.
Hello.
Because
Now-
my internet was lost. Yes.
Yeah. Now
My
it's
internet
fine.
was lost. Okay.
Sir, I think it's a categorical data. That means it's a nominal scale. So
Please show your face. Show your face. Why are you?
So
Okay.
nothing.
Thank you. Tell me.
So most probably it will be non-normally distributed data. So non-parametric tests will be used.
Exactly. So that's why I have not made two segment. Now you see here I have put two segment. One segment here, one segment here. One is brown, one is blue. But here only I have put only one green. That means it is completely the non-parametric test. Parametric test will not come because chi-square test and Fisher's exact test, they are related to each other. If a chi-square test will not be applicable, at the same time the Fisher's exact test will come up. So for that reason, they are under the non-parametric test. So now one thing is confirmed, that means all the green symbols are under the non-parametric test. Clear? Getting my point or not? So, but one thing you have to know, that logistic regression, already I discussed in the previous slide. So when you will go for the logistic regression, there is a debate. So to avoid that debate, you have to defend yourself. Logistic regression is not under the non-parametric. It is under the parametric because it is leading towards the normality distribution, because we are under the social science people or social science segment. For that reason, it is very difficult to have the normality. So it is close to the normality. That's why it is the dummy for the probic model. So for that reason, if you will see in that line, the logistic regression will be under the parametric test, not under the non-parametric test. But if you will see the core nature of the logistic regression is not approaching towards the normality. That's in that angle, it is non-parametric. But usually, when we are discussing deeply, we are telling it is under the parametric test. Clear? Because it is the proxy of the probic model. Okay. Anyhow, so these are the different things in the different three slides I have shown how to do the test in different ways. So now the next slide I have to show you now. Let me see. Yes, here it is. So now we have to go. Yes, now we minimize it. Yes. Now, is it visible? Statistical tests in not cell. That means just I have taken some important things with the type of data needed, test statistics, and what type of example will be there that we have to see under this slide. So now you see, I have chosen 1, 2, 3, 4 major statistical tests, which is commonly used by each and everybody in day-to-day life. So that I have picked it here in this slide, because already we have understood many things, where we have to use parametric, where we have to use non-parametric, and how we have to take the different types of variables, how we have to take different scales. In that regard, also we have seen the parametric and non-parametric test, even the one group and more than one group, more than two group, more than three group, paired and non-paired.
Just a minute, I think I've lost the network. I think, that,
Can I say something, sir?
yeah, just give some time, and just I think now recording is going on. So just wait for 1 second, then I'll tell something.
Good afternoon, sir.
Good afternoon. Yes, Manoj, you want to say something?
No, it's okay, sir. It's fine.
Just wait for 1 second. Then I will elaborate. I'll stop recording and speak. Understand, in the Gujarat it is very difficult.
Is it audible?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Because internet is intermittent.
Yes, I understand. I understand, sir.
Because rain is also there. In spite
Yes.
of that. So now, please, audience, please, is it visible now?
No, no, sir. No, slide is not visible. You just share 1 second.
Okay, okay, okay. Just let me share now. I think it is visible.
I hope it comes.
Yes.
Give 1 second.
Yes, it is visible. I hope so.
No, sir. Not yet.
Not yet
Yes, sir.
visible.
Visible, sir.
Yes, visible.
Yes, sir, visible.
Visible.
Yeah. Okay, now you tell me. I'm asking the question because already I have done many things. Now, from the example point of view, you have to tell me whether it will be the parametric test or non-parametric test. So now, example already I have told, are blood pressure and weight correlated? Here. So, what type of test I am going to use? Pearson's R test. So, Pearson R test is under the parametric or non-parametric? Tell me. Which test we have to use it from the example?
Parametric, sir.
Nothing is there. Nothing is there. Even data set is not there with you. Listen me. Previously, I told you you should have the data set, or you should have the scales, and or you should have some sort of exposure groups like that. But now I am telling nothing is left. Nothing is there. Exposure group is absent. Scale is absent, and your what I can say, the variable is absent. So now I am only giving you the example. So now you are a researcher and you are doing your research and you are visiting to the field, and in the field you are finding some live examples, and from that example how you will relate with your test statistics and how you will come to the conclusion whether you will choose the parametric test or non-parametric test. So that answer I need from you from this slide. So this slide is completely considering about the example. So from example, how you will come to know whether you will use the parametric and non-parametric test. Tell me. Please, one by one. Yes. First, you tell me your name and open your face. Show your face, please. Yes, please. Yes, Seema.
This is
Seema,
parametric test.
Parametric test. Why it is parametric test?
Because continuous variables are there, and we have to measure blood pressure and weight. We have to correlate them, whether they are associated or not.
Okay. Any other thing? Because main thing you are leaving, I think so. Main thing you are leaving. Main thing. Anybody else? Please?
Normally distributed, sir. Normally distributed.
Yes.
Because many times I'm telling the same thing. You have to pick that either or. So that is the real answer. Thank you very much. Okay, next. So now let us say next example is there. I have shown you the 4 examples. The second example, you are in the field and you are finding the second example. 2 normal weight. Group 1. Patients have lower blood pressure than obese patients. Group 2. This type of situation you are finding in the medical. You have visited one hospital and you are doing your field research in the health economics or health related research. You have done it and you are pursuing that health related research, and you have found this example. So what type of test you are going to use? So now I have given the answer, that student test you have used from this example. So now students T test, which whether it is parametric or non-parametric, tell me. Anybody else, please? Yes. Yeah, Lavanya Vingare. Yes, please open your face. Show your face, please. Show your face.
Good morning, sir.
Very good morning. Tell me.
Sir, I think
It is
it's
student T test. Parametric test. Why? Because this leads to the normal distribution. Either T test you can do it or ANOVA test you can do it, isn't it? So now you see properly from the example we are coming to know whether we are going for the parametric and non-parametric with the particular test. So now the third example is, are obese individuals, obese versus not obese, significantly more likely to have a stroke versus non-stroke? Anybody else, please? Why I have used the chi-square? Already I have written the answer. Now my question is, why I have used the chi-square test here? Can you tell me, anybody? This is the very fundamental question. Yes. No, basically already you have told. I will not allow you. Though you have raised the hand, I know it. If somebody will not be giving the answer, then I will invite you once again. Yes, Sadhana Singh. Yes, open your face.
Yes, sir. It should be non-parametric test.
Yes.
Why? Test should
be, my question. Listen me. My question is, why it is chi-square? Why it is chi-square?
Individual. Yes, sir. Because the obese people, we cannot have a continuous variable or normally distributed variable for obesity related peoples.
No. Anybody else, please? I'm not convinced. Though you have tried, I will give you the exact answer if somebody is not convinced. Yes, Seema Hermani, already you told. I will not give you the chance. Anybody else, please? Yes, please.
These are categorical variables.
Seema, already you told, na? Okay, let other give the chance. Yes, please. Manisha Kumar, please.
Sir, I think comparing to comparison between that.
No. Anybody else, please? Thank you. I will come. Yes, anybody else, please? Okay. Yes, Banajaki. Yes. Banajaki C. Ravadigar. Please show your face. Yes, please.
Yes.
Yes.
So it is non-parametric test, chi-square.
Non-parametric test. It is well understood. It is non-parametric test. But my question is, why it is chi-square? Why it is not other? Why it is chi-square?
We are comparing the expected variables with observing.
That's fine. That's fine. That is the main theme of the chi-square test. When we are going for the chi-square, expected and actual, we are taking in the comparison. That's not the issue. What is the main issue behind it? Can you tell? Yes, you are coming to some points. No problem. That I appreciate. But exact answer I need. Yes. Exact answer I need. Because we should be pinpointed. Yes. Anybody else, please? Yes, Tanushree Das. Yes.
Yes, sir. Sir, as you mentioned, categorical variables, they follow non-normal distribution. So because of that, we have to use non-parametric test.
That's true, because that slide I read. But something new I have to know from here. Okay. So now let us stop. Now I'm giving you the answer, all of you. So now you see the main intention behind the using of a chi-square test is independent test. Now you see, obese and non-obese, they are independent. They are not related to each other. Whether somebody is more fatty and somebody is less fatty, they are unrelated. They are not related to each other. So when we are relating the unrelated activities, at that time we are using the chi-square test. That means independent test. Already I told you in the previous slides. Chi-square test, other name is the independent test. So obese and non-obese, they are independent to each other. They are not affecting with each other. Are you getting me? Yes, boys and girls.
Yes.
Are you understanding now?
Yes.
So my question is, why it is chi-square? It means it is an independent test, because obese and non-obese, they are not affecting each other. If somebody is growing, somebody is not growing, that means those who are not growing, they are pushing the growing people that yes, you should grow, then I will not grow. And is it there? No. So they are independent. So because of the independent state, chi-square is clear. Here. Then last part. Last example. You are visiting the same hospital or same area. Does obesity predict stroke versus non-stroke? That means, heart stroke. Usually, right now, heart stroke is very common in everybody's life, even in anybody's house and home. The heart stroke is common. So that example I have taken. Does obesity predict stroke, stroke versus non-stroke when controlling for other variables? And here I have taken odds ratio, because odds ratio is important to know the logistic regression, because when you will go for assessing or estimating or predicting the logistic regression, odds ratio is important parameter. If you are not knowing the odds ratio, then it is very difficult to understand and estimate the logistic regression. So now you tell me that odds ratio, that test statistics, OR ratio we have taken, and 95% confidence interval we have also taken. And the variables type also we have taken. This is dichotomous variable as the outcome. So now can you tell me whether we are using the parametric and non-parametric, and if it is, and why? Tell me. Floor is open. The last question from this slide. Yes. Anybody else, please?
So this is a this is a parametric test, but logistic regression follow the pattern of normally distributed. So
no, you are putting wrong things. It is not following normal distribution, it is approaching towards, not
yes,
following.
Approaching
The word you should use properly.
No, it is not
Because
parametric.
it leads to the probit. It leads to the probit. As we are in the social science group, we are unable to handle the probit because we cannot touch that normality. So we are below the normality. That's why we are using the logic. And though the logic, in spite of that, the logic is following the trend of the probit. Because if same data you will put, the result will be coming in the similar way, almost with little bit differences. So that's why we are not hesitating to tell that logistic is under the parametric test. Though by nature it is what? By nature it is non-parametric. But when we are seeing this thing, it is under the parametric. Clear? Thank you very much. So now we will go to the next one. So I think in your concepts, most of the things we have finished. So now this is the statistical test. Another one is the example use case and assumptions, use, and statistical test. So this also I have prepared. This is the statistical test, t-test, ANOVA, chi-square test, Pearson correlation, regression analysis, Mann-Whitney, Kruskal-Wallis.
Request.
Yes. Hello.
Sir, sir.
Tell me, sir.
People have, sir, only one request that you just take, if some students have any clarification, any doubt related to that, you just take that questions from this.
Okay, please raise some questions if you have, because already it is 1 o'clock. Almost most of the things we have covered as for the things. So now you can ask.
Sir, yes, sir. Good afternoon, sir.
Tell me,
This is
Rajeshwar.
Rajeshwar. Sir, here chi-square, sometimes they are calling goodness of fit.
Yeah.
Why, sir?
Goodness of fit. Okay, fit. Now you see. Chi-square, the first of all. Chi-square is what? It is a independent test. Isn't it? The first principle is it is a independence of test. Already recently I told. So goodness of fit, it means goodness of fit. Means fit का goodness है. हिंदी में इसको बोलते हैं, इसको यदि translate करें. So when the two variables are independent with each other, we are unable to establish the relationship that whether they are properly fit or not. They are properly fit or not. So to assess that whether there is a good fit or not, so for that reason we are assessing the chi-square, and that will be used only when the variables are independent in nature. If they will be dependent in nature, we cannot use that. We can use another goodness of fit. Another goodness of fit is there also, but that chi-square goodness of fit we cannot use. Goodness of fit has different techniques, and chi-square is one of the techniques. And goodness of fit for that independent mix. And if the variables are the dependent, the goodness of fit will not come in form of the chi-square. There is another technique. Getting my point? Hello.
Yes, sir.
Rajesh?
Yes, sir.
Rajesh?
Yes, sir.
Okay.
Yes, sir.
So this is the thing. That means this goodness of fit is coming with respect to the independentness of the variables. And once the variables will be in the dependent format, this chi-square goodness fit will not be applicable. For that reason, another goodness of fit will be there. Clear?
Yes, sir.
Anybody
Thank
else,
you, sir.
please? Welcome.
Sir, what is the meaning of repeated measures ANOVA? Is it two-way or three-way ANOVA?
Please, once again, please.
Sir, what is the meaning of repeated measures ANOVA? Is it two-way or three-way ANOVA?
Repeated measure ANOVA. So you have not seen the slides when I used it repeated, where it is repeated. Just a minute. I'll show you. Yeah, there it is. 1 second, I'm coming back. The first slide. Yes, just tell me. I see this thing. Is it visible to you? Is
Yes,
it
sir.
visible? Now
Yes,
you
sir.
see. This is on-matched group. This is repeated measures, more than one continuous observed things. Now it is parametric PRT test, isn't it? And if it is on-matched, now more than two groups, it is one-way ANOVA. And if it is two groups, it is only independent sample test. And now you see, your question is here, repeated measures ANOVA. Am I right? If it
Yes,
is,
sir.
if it now you check it, now please make the screenshot in your mobile also. Repeated measures ANOVA, it will be parametric. Condition is that more than two groups will be there, and that more than two groups should be in the repeated format. More than one continuous observation concept. Clear now?
Sir, can we say that it is two-way ANOVA?
Yeah, we can say in this way, but exactly if you will tell repeated measures ANOVA, it will be well and good.
Okay,
It will
sir.
be well
Thank
and
you, sir.
good. It will
Sir,
be
one
well
more
and
doubt.
good. Yes,
Sir,
tell
what
me.
is the meaning of OLS properties? You showed
OLS?
one properties, sir. OLS.
Okay.
Yes, sir.
OLS, ordinary least square.
Yes, sir. Yes, sir.
Okay. Ordinary least square, there are, 5 to 7 conditions. Please write it on first condition. Should I type it?
Sir,
Should
as
I
you wish,
type
sir.
it?
You can speak or you can type, sir, as you wish.
Okay. So now, chat. In the chat, I'm doing the first one. Linearity. Sorry. Linearity. The first condition is linearity. Are you getting the linearity? Clear?
Yes, sir.
The first assumption. What is the linearity? Means the equation must have the maximum power of 1. Clear? The equation power must be 1, maximum. That's the linearity. Equation must follow the linearity. Clear?
Yes, sir.
Second, no multicollinearity. Are you getting? No multicollinearity. What does it mean? No multicollinearity means the multicollinearity will come if there is more than one independent variable. And in the simple linear regression, multicollinearity is absent because multicollinearity will come if more than one independent variable will be there. Means if there is a correlation between two independent variables, then we can call there is a multicollinearity. And if there is multicollinearity, OLS cannot be applied. Clear? So no multicollinearity should be there. It means the two independent variables should not be related with each other. Clear? Clear?
Yes, sir.
No autocorrelation. No autocorrelation. Getting my point? No autocorrelation. What is the no autocorrelation? All types of regression equation must have the random variable. If it is not having the random variable, then we cannot call it as the econometric model. There are two types of model. One is mathematical model, second one is the econometric model. So now we are in the stage of the econometric model, not in the mathematical model. In the mathematical model, randomness is absent. That means the stochastic factor is absent. The random factor is not there. What is random factor? Let us say you are moving with the bike or the car. Immediately some rain is coming, some storm is coming. It was not expected in an advance. So suddenly it came. So that is the random factor. That is the stochastic factor, which is unexpected, which is beyond your control. So that's the random factor. So if two random factor, if two stochastic factor are related to with each other, then the OLS cannot be applied. So for that reason, the no autocorrelation must be there. That means two consecutive random terms should not be interrelated. So that's the condition. That third condition. Clear?
Yes,
Hello?
sir.
Okay. Then fourth condition. Fourth condition, there should be homoscedasticity, no heteroscedasticity. No heteroscedasticity. No heteroscedasticity in the equation. That's the fourth. What is heteroscedasticity? Heteroscedasticity means there is no homoscedasticity. So no heteroscedasticity means there must be homoscedasticity. That means our econometric model must have the homoscedasticity in nature. What does it mean, homoscedasticity? Homoscedasticity means the variance must be constant. That means the constant variance we must have. The constant variance we should have. That means other name of the no heteroscedasticity is the constant variance. That means when the independent variables, the size of the independent variable will increase from 1 to 2 to 3 to 4 up to the infinity, the variance should not increase or decrease. So how we will measure the variance? So let us say one range is there. That means a two lower range is there and upper range is there. And within that two range, the curve should move. Curve should not move beyond the upper limit and curve should not go down below the lower limit. That means between the upper limit and lower limit, the curve should be moving and the equation or the trend line should be moving. So that's known as the constant variance. That means the data is trending constantly. Data is not going beyond the upper limit. Data is not going down the lower limit. So that's the constant variance. So if constant variance is not there, if no homoscedasticity is not there, if heteroscedasticity is there, then you cannot use the OLS. That is the fourth condition. Fifth, no relation between explanatory variable and the random variable. So this is another condition. What is explanatory? Explanatory means independent variable. So there should not be any relationship between the independent variable and the random variable, means stochastic variable. If there is some sort of relationship between the stochastic variable and the independent variable, the OLS cannot be utilized and OLS cannot be used. So that model is invalid. So we cannot use that. And the last but not for the least, normality, which is most important one at the end. Normality means data must not be skewed, either the positive skewed or negative skewed. It must be 50-50%. Left side 50%, right side 50%. You know, in the temple there is a bell, and you are hanging the bell. Ting, 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 the bell. You know the bell shape. So why it is called the bell shape? So if you will see the bell, it is exactly 50% towards the left and 50% towards the right. So that's why it is called the bell shape curve. By following the bell, it is called the bell shape. So other name of the normality is the bell shaped distribution curve. So if data is following that bell shape, if data is following that normality, then OLS can be utilized. So more or less, the normality is more important. If data is following the normality, other things will come automatically. Other things will come automatically. That's why today lecture, when we are dealing with the today lecture, we are focusing on the normality to choose the parametric and non-parametric. So main difference is that parametric is having the normality and non-parametric is not having the normality. So that's the main difference, and that was the key message in today's class. Okay, so
Thank you,
these
sir.
are the assumptions behind the OLS. I think your query is done. I
Yes,
hope.
sir. Thank you, sir. Thank
Are you
you, sir.
satisfied?
Yes, sir. Sure, sir.
Thank you
sir.
very much. Anything? Anybody else, please? Because time is not there. Because many things I have to show, but time is not there. But I have to go to the deep now. That's why I have given the different aspects of how you do the different tests. And anyhow, all the contents we have managed it with the different slides in different way. Okay. Anyhow, please, Tanusri Das, are you asking?
Sir, yes, sir. Sir, in one of your slides, slash Fisher's
One of
exact test. So what?
Which one? Which one? Can you tell me? Yes. I got your point.
Yes, sir.
Yes. Chi-square test slash exact
Fisher's
test. Am I right?
test. What? Yes, sir. What is the difference between these two? Yes, sir.
Yeah. I'm telling you the difference. That I promised. While I was showing the slide, I was telling that later on I will tell. But anyhow, I forgot. Now you have recalled it, and you have remembered me. So now you see. Chi-square and Fisher's exact test. Both are under non-parametric test. First one. Second one. When the chi-square test will be utilized? When the Fisher's exact test will be utilized. So many people, they are confused. And most of the people, what they are doing, they are using the chi-square test without knowing the basic condition imposed behind them. So what are the conditions? Simple condition. Remember, leave all the matter. Just come to one conclusion. Chi-square test will be utilized if and only if greater than equal to 5 groups will be available. Clear? Greater than equal to 5 groups will be available. 5 expected result, 5 actual result, you will get it. If, because chi-square will be done through the expected output and the actual output. Na? These two outputs are important. Am I right? Yes. Tanusri.
Yes, sir. Yes, sir.
Are you getting
Yes, sir.
So,
Yes,
if and only if 5 greater than equal to 5 groups will be available, you are eligible to use the chi-square test provided the two variables are independent with each other. Clear? These are the two conditions.
Yes,
Nothing beyond that. Second, when you will use the Fisher's exact test, I told you. Fisher exact test is also coming under non-parametric test. When you will use, suppose you are in the field, you are having less than 5 number of groups. At that time, You are not eligible to use the chi-square test. Could you leave the project? If you come to me, I will tell no. Why you will leave? Do it. Then what type of test? At that time, Fisher's exact test you can use it. This is the main difference. Both are non-parametric. Fisher's exact test will be utilized if the groups are less than 5. If the groups are exactly equal to and greater than the 5, chi-square test. Clear?
Yes, sir. Thank you so much. Yes,
Clear?
sir. Thank you so much.
Thank you very much. Welcome. Anybody else,
Sir,
please?
Sir, please explain. Logit model is used in social science. Probit
Yes,
model
yes,
is
yes.
used in medical science. And Tobit model.
Medical science, probit. Medical science logic is not applied.
Or
Because
some cases Tobit method is used in economics. So please explain how.
listen, good question. The Tobit model will be utilized only when the latent variable will be there. Latent. What is the latent? It's hidden. You do not know. But it is not exactly related to the stochastic variable. The stochastic random variable and the latent variable are two different things. The latent variable is the hidden variable. For example, I am saying that a vehicle or a car, we have set one target for the green culture. We are coming to the environment, and mostly the environmental scientists, those who are in the environmental department, forestry department, and sustainable development, those who are working in that field, they are using this one. Also in economics, we are using also, and even in the road accident cases also we are using. Let's say, I'm telling you one example. For example, if I'm saying a traffic post is there. In the traffic post, there is a signal, speedometer signal is there. Am I right? Have you seen it? All people, you have seen it.
Yes, sir.
Speedometer. And especially the speedometer is seen in most of the metros, and even nowadays everywhere it is available. Speedometer to control the pollution from the vehicle. Am I right? And
yes, sir.
And what the speedometer is doing? Speedometer is some criteria is followed. What is the criteria? Your speed must not be more than 40 kilometers per hour, 40 to 60 kilometers per hour. Am I right? Am I right?
Yes, sir. Yes, sir.
So if truck will move after 60, definitely he will be caught. If below 40, he will not be caught. Am I right?
Yes, sir.
So now what we are observing? We are observing if car is moving beyond the 60 kilometers per hour, he will be penalized by the court of law, and automatically the challan will be going to his home. And the very next day, he or she has to pay it either online or physically he has to go and pay it. Am I right?
Yes, sir.
For those who are driving below 60, no penalty is coming. Am I right?
Yes, sir.
In the same day, if 3 number of cases are observed, that means the speedometer will catch only 3 cases. Am I right?
Yes, sir.
But how many cars moved in that way? More than 1,000. More than 1,000, maybe. But only 3 are caught because they were passing the set limit of 60. Am I right?
Yes, sir.
So we are not considering those who are running below 60. So they are the hidden. They are the hidden vehicles. That is the latent variable. They are the latent variable. They are visible, but they are not recorded. They are hidden, but they are not unexpected. In the random variable, what I told, random variable is unexpected. But these 1000 vehicles are expected. It is known to everybody in an advance. So this is the main difference between the latent variable and the random variable. So when latent variable will come, that time you are supposed to use the Tobit. That is a Tobin-Probit model. Because Tobin was the economist who developed the Probit model, then he linearized it, then it is called as the Tobit model. And most of the environmentalist people and the medical people, they are also using the Tobit model, and it is a good model. Any questions,
Sir,
please?
it mean when the Latin variable is available, then we go for a Tobit model.
Definitely.
Or Latin variable is that variable that is not be it present, but this not be observable.
Yeah.
Okay, sir.
But you cannot say that it is not it is not expected. It
It
was
is exit.
expected.
Yeah,
was
it is exit.
expected.
It is exit, but this is not a part of our objective to see whether it is
Right,
penalized or not
right,
penalized.
right. And in
Okay.
that case, many studies will be there, whether it is towards right, whether it is towards left, many things are there. So when we'll come to that topic, then we will go for that, because one topic I have written for the IGNU. So those who will be studying in the IGNU master degree program, one chapter I have written for the IGNU New Delhi in the Tobit model. So maybe in the month of July it will be published, and those who will be enrolled in after the July 2024, they will find my book under the IGNU under the Tobit model. One I have written the Tobit model.
Okay. Thank you, sir. Thank you so
Welcome.
much.
Anybody else, please? Interesting. So this type of thing I did it, and what I expected I'm getting.
Sir,
Hello,
I
sir.
have one question, sir.
Tell me. Ajar Iqbal. Na Venkatesh Betigiri. Okay. Yes, Venkatesh ji.
Yes, sir.
Venkatesh ji.
Yeah,
tell me.
I'm interested in a small case, in a small study. What I want to do is there is one method. For example, let us say the gym method, and in that gym method, I will measure 5 parameters. Then in the yoga method,
Can you write me, because what you are telling, it is not audible to me properly. Can you type
Okay.
it what you are telling? Just to type that exact word.
Yeah.
Just type it.
Yeah.
Just type it the exact word.
Yes. In the meantime, you can take the question from somebody else.
Okay. By that time you can write. Okay. I'm following also. Yes. Anybody else, please?
Yes, sir. I have one question, sir. You have told that, sir, when the more than 5 groups are available, then we have to use the chi-square test. Sir, can you explain with an example?
Listen me. Not more than 5. Greater than equal to. That
Yes,
is the
sir,
word.
greater than equal to 5
Greater
groups.
than equal
Sir,
to. Minimum
sir,
it
can
should
you
be 5.
explain? Sir, can you explain with an example, sir?
That means I should go to the slides. Already I have done it. I have to go to the slides, or else you mail me. I will send you. You take my
Okay,
mail.
sir.
You take my mail and I will give you. Okay.
Yes, sir. Okay,
Just I'm typing my mail. Akshaya. It is there in my slide. Also, it is there, because that was the estimation part. That's why I didn't touch it. Just a minute. Say at the rate of MZU. That is U. That's in. This is my official university ID. So you can all people, if somebody is having something, they can touch me over this email ID, and the answer will be given to you over this class. Okay.
Sir, next question is, sir, what is odd ratio in logistic regression?
Odds ratio. Now you see the logic model. We are going for probabilities. That is concentrating on the probability. The probability of success over probability of a failure. Clear?
Yes, sir.
Means, let us say two events are there because it is dichotomous, either or. Let us say if you climb to the Utop Minar in New Delhi, and after reaching there, you are telling to your friend, after reaching there, with a laugh, you are telling, my dear friends, let me jump from this peak. What will be the probability of my life? What will be the probability? Can you tell me?
0%.
Either or. Either you will live or you will die. Yes or no?
Yes, sir.
Either you will go to heaven or you will be at this earth. In between it will not be there. Am I right or not? Because it is a such height. It is such a height. If you will fall from that, chance is either you will die or you will survive. Either or. And that is usually called as a dichotomous. And this dichotomous word is a simple term used by the US people. So for that reason, we are telling US people are a dichotomous people. They do not know the intermediate thing. They are knowing either yes or no. If you will argue with any US people, they will tell with disgust, you just tell me yes or no. They do not know the intermediate word between yes and no. But we Indians, we know what is the intermediate. So that dichotomous word is coming from the US, not UK, not from anywhere. So anyhow, so now I am coming to the point that that odds ratio. Probability of success, how much? Probability of failure, how much? Okay. So now, if you will sum the probability of success and the probability of a failure, it should be 1. It should be 1. Or it should be 100%. Either or. Some researchers are taking 100%. Some researchers are taking as 1. Both are correct. If it is 1, it will be 0 to 1 in between. 0.5, 0.5, 0.6, 0.4, 0.3, 0.7. So almost when it will you will sum it, it will be 1 exact. And if it is 100%, maybe 0.5, 0.5 means 50%. Another 0.5 also 50%. So probability of success over the probability of failure. Probability of success in the logic model, we are calling it as the P, letter P. P over Q. Okay. So what is Q? Q is 1 minus P. Because whatever left from P, that is the failure, na? Am I right?
Yes, sir. Yes, sir.
So ratio of a success to the ratio of a failure is your odds ratio. Clear?
Okay, sir. Thank you, sir.
Clear?
Yes.
Probability of success over probability of a failure. P over Q, where Q is the 1 minus P. If you know the P, automatically you can know the Q. If you know the Q, automatically you know the P, because there is no such third variable. Either P you can get or Q you can get. Either or. There is no such a Z, there is no such X in between the P and Q. So either you can click it or you cannot click it. If you will click 70%, means chance upon clicking is 30%, 100 minus 70. Let us say if you will know the on clicking 60%, means your probability of clicking is 100 minus 60, 40%. So if you will make the ratio of these two extreme cases, the probability of success and the probability of failure, that will give you the odds ratio. And that is the base for forming the logic model or the probability. Anything else?
Hello.
Vaisali.
Yeah, sir, one question is, if outcome variable is a construct called neighborhood attachment, in which I'm asking the students how many are their favorite number of places. So they give me some number. And then there is this composite variable of neighborhood attachment is made up of two sub variables. One is their favorite number of places, and the other one is their sense of neighborhood attachment. Like asking them questions whether you feel that your neighborhood is friendly, not friendly. You get to do what you think you like to do. So that is answered in Likert scale, like 0 to 5.
Yes.
Agree not. So can I combine these two as a metric variable?
Now it is in the Likert scale, okay?
Yeah, one is Likert scale, one is a number of favorite places. Number of favorite places in the neighborhood, like park, garden, whatever. So he will be giving me some number. And that number.
But Likert scale, you are not getting the number. Now you will get some ranks 1, 2, 3, 4, 5. Middle is 3rd and extreme is 4, 5 and lower is 1, 2. Am I right?
One is not at all agree and 4 is agree a lot.
No, that is common because Likert scale you cannot change it. So that is common understanding. So you cannot change it. 1, 2, 3, 4, 5. 4, 5 means you are extreme good side, and 1, 2 means extremely bad side. And 3 is the middle side. Am I right?
Yes, and the number of places also I have categorized them, like from 0 to 2 number of places, then 1 rank, like that. If it is saying 15 numbers, then it becomes like too much. So I have categorized them after they give me the numbers.
Can I know your equation, because that I need to know. What type of equation you are going to introduce?
So this is a dependent variable. And
dependent variable is which one?
This one, neighborhood attachment, which is
neighborhood attachment is your dependent variable. Okay. Then what is your independent variable?
Independent variables are all the metric variables of built environment in the neighborhood, like density, number of intersections, and available footpath length ratio. So like that, 7, 8 independent variables are there, which are all metric variables measured in GIS.
All independent variables are metric variable.
Yeah, measured in GIS.
Measured in
GIS.
GIS means the
Geographical Information System.
Okay, GIS. Okay. So you are from geography?
Architecture.
Architecture.
Yeah.
Okay. So dependent variable neighborhood, whether neighborhood has some sort of classifications or what?
There are 5 neighborhoods.
5 neighborhoods. Okay. Got it. 5 neighborhoods means 1, 2, 3, 4, 5.
Yeah, and then the neighborhood, the GIS is being the neighborhood is the variables of neighborhood are measured in 400-meter radius from the child's home. So like that, if I have 300 children, then that way I have 300 buffers.
Okay. Do one thing. I got your point, because I got your dependent variable. Your dependent variable is 1, 2, 3, 4, 5. Is it in a rank order or is it in the non-rank order? Can you tell me? Just give me some information about the dependent variable.
I have taken it as a continuous variable, metric one. Dependent.
So how you are telling 1, 2, 3, 4, 5? I'm asking you that I want to know that whether you have taken the dependent variable as the ordinal variable or the non-ordinal variable. Ordinal variable means 1, 2, 3, 4, 5. Okay. And the continuous means, or the discrete means, the exact figure will be there.
So right now I have
nominal or ordinal you tell? Nominal or ordinal?
Ordinal I have taken.
Ordinal. Okay, got it. So this is ordinal. So now you can do one thing, ordinal logistic regression, you can do it. Got it. Ordinal logistic regression. One of my paper is there in the ordinal logistic regression, and nowadays the good improvisation is there in the ordinal logistic regression model, isn't it? So you can use it, and here the multiple regression, multi-logic regression analysis cannot be utilized because you are using the rank and ordinal.
Okay. Thank you.
So irrespective of the independent variable, I am least bothered. For that reason, I was checking that what is your dependent variable codings. So dependent variable coding is ordinal in nature. So ordinal logic model will be utilized. So that is your fixed model. And if you want to know more things and more details, so if you will share me your data sets, what is the dependent, what is the independent. So after checking the nature of the data and the behavior of there, then I can suggest some other things if something will be.
Okay, thank you.
But right now it is for you. This is the ordinal logistic regression model. Already I have done it, and if you go through my CVs also, you can find one food security article I published, and in that I use this ordinal logistic regression model.
Okay.
Thank you very much.
Thank
Anybody
you.
else, please?
Sir, please, from where this article can I reach?
Google Scholar, you do it. Google Scholar link already I have just put my name and it will come. Food security will get it.
Okay, thank you, sir.
On food security, I used the ordinal ordinal logic regression.
So I think last question. I think sir is speaking continuously since more than close to now.
It is because of you, sir. Because of your motivations.
No. It is our missions. So we are doing it. So I think last questions, and we should give break, and then if you have one question.
Achha, let me tell some. Venkatesh Betigiri has asked. Method 1 is gymnasium, method 2 is yoga, method 3 is refining exercise. Duration of each method is different. So yes, Venkatesh ji, actually,
Yes,
what you are asking, because method 1, method 2, method 3, I can't get to the point. Can you elaborate on this? Now I'm getting from your text. Can you tell me what you are actually wanting to know?
Yeah. Each method, I want to measure 5 parameters for about 50 people or 100 people.
Now
How
you
do I go
see,
about it?
now you are talking about the sample. So when the sample case is coming, we have to see the population first of all. So I do not know the population. I cannot suggest now. So I have not any idea on your area also. So once I will know the area, once I will know the population of the area, and once I will know your variables, then I can suggest something, how many sample you have to collect, and then after I can suggest you that actual which method of sample you can take, so that appropriate thing will come. Because there is a saying, larger the sample, better the result. Lesser the sample, worse the result. So for that reason, we are capturing the good sample from the good technique and good methods. So first of all, what I told, I want to know all these things, or else I cannot tell anything. If I will tell something blah 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 blah, you will be satisfied and the audience will be satisfied. At the end of the day, you will not get any result. So I am not that kind of person to make you and give you the bluff things without
Yes, sir.
doing
Accepted.
anything. Thank you
Accepted,
very
sir.
much.
I will email you the details.
No
Thank you, sir.
problem. No problem. Thank you very much.
Okay. So any other questions if you have?